Cambricon reported something close to a 453% profit surge in its most recent filing, and its chips are sold out. Every buyer who wants one is being told to wait. On paper, that sounds like the best problem a chip company can have. More demand than supply, proof the product is working, money coming in faster than ever. Except the situation is not what it looks like, and the reason why tells you something precise about how export controls actually function in the real world. Before you land on the obvious answer, they just need to ramp production, give it a quarter. That is exactly the assumption worth pulling apart. Because if this were a scheduling problem, it would have resolved by now. It hasn't. The sold-out status has persisted, the wait lists have not cleared, and the constraint keeping them that way is not inside Cambricon's walls. It was never inside Cambricon's walls. Here is what is actually at stake. If a profitable sold-out chip designer cannot convert demand into revenue by simply ordering more chips, the problem is structural, not operational. And if it is structural, it does not apply only to one company. It applies to every Fabless artificial intelligence chip designer in China sitting in the same position. That is a much larger story than one company's earnings report. To understand it, you need to understand how Cambricon's business actually works. Cambricon is a fabless chip designer. It writes the blueprints for its chips, the architecture, the logic, the instruction set built for artificial intelligence workloads. But it does not operate a single piece of manufacturing equipment. It does not own a fab floor, does not run a furnace, does not spin a single silicon wafer. This is a completely normal and extremely successful model. The logic behind it is that chip design and chip manufacturing are different businesses, and specialization makes both better. A fabless company focuses entirely on design and hands the physical production to a foundry. In theory, this makes scaling easy. Want more chips? Place a bigger order. Think of it this way. A fabless designer is an architect who draws the building but has never owned a crane or poured a yard of concrete. Normally that is fine. You hire a construction firm. The problem comes when there is only one firm in your city licensed to build exactly what you need, and that firm has run out of permits to expand. The architect's drawings are perfect. The demand for the building is real, but the permits control everything that happens next. In China's advanced node semiconductor landscape, that construction firm is SMIC, the country's most capable domestic foundry. In practice, for fabless Chinese chip designers who need production at the process, generations required for competitive artificial intelligence accelerators, SMIC is effectively the only viable domestic option. The reason Chinese designers cannot simply route their orders to TSMC in Taiwan or another leading-edge foreign foundry is that U.S. export controls restrict those foundries from manufacturing for Chinese artificial intelligence chip companies, subject to relevant restrictions. So the order goes to SMIC. The question then is what SMIC can actually build, and where its ceiling comes from. SMIC was placed on the U.S. Department of Commerce Entity List in 2020. That designation limits what American companies can supply to it without a license, including semiconductor manufacturing equipment. Separately, the United States government and the Dutch government have blocked the export of extreme ultraviolet lithography machines from ASML to China. Extreme ultraviolet is the technology that leading-edge fabs use to print the most precise circuit patterns onto wafers. Without it, you cannot efficiently manufacture at the most advanced process nodes. Here is the important technical detail, and the reason the situation is not simply hopeless. SMIC has demonstrated that it can reach competitive process nodes anyway, by using a technique called multi-patterning with older deep ultraviolet equipment. Instead of printing a pattern in one exposure pass with extreme ultraviolet light, you print it in multiple passes with the tools you already have. The Huawei Mate 60 Pro phone, released in 2023, contained a chip that independent analysts at TechInsights and others reverse-engineered and confirmed was produced at a competitive advanced node using exactly this approach. The chip was real. The manufacturing was real. SMIC did it. But the workaround carries a cost. Multi-patterning with deep ultraviolet equipment is slower per wafer and more expensive per wafer than extreme ultraviolet production at the same node. And critically, it is harder to expand. Adding capacity in any fab requires acquiring more equipment. If the equipment you need to grow your advanced node capacity is on a restricted list you cannot purchase from, your advanced node capacity is effectively fixed at whatever you manage to acquire before the controls tightened. You can optimize what you have. You cannot meaningfully multiply it. This is where the sold-out shelf connects to the wafer slot that never opened. When Cambricon needs more chips to fill its backlog, it places a wafer order with SMIC. SMIC allocates wafer starts, each one a reservation on the fab floor, a slot in the production schedule where a silicon wafer will be processed into chips. If the total number of wafer starts SMIC can allocate at the relevant advanced nodes is fixed by its existing tool inventory, and that tool inventory cannot grow because the required equipment is export controlled. Then Cambricon's chip output is capped by a number Cambricon had no hand in setting and cannot negotiate its way past. Paying a premium might shift priority within the existing pool. It does not create a new pool. A wafer start is like a reservation at the only restaurant in the city that knows how to cook the dish your customers keep ordering. When the restaurant is fully booked and cannot expand its kitchen because the equipment supplier will not sell to this zip code, it does not matter how many customers you have or how much they are willing to pay. The reservation list just gets longer. So Cambricon's ceiling is SMIC's ceiling. But SMIC's ceiling did not originate with SMIC either. The controls on extreme ultraviolet machines and advanced deep ultraviolet tooling were not designed to target Cambricon. They were designed to prevent China from building a self-sufficient, leading-edge semiconductor manufacturing base. The downstream consequence, though, is that every fabless Chinese artificial intelligence chip designer who needs advanced node production shares the same constrained resource. The export policy aimed at a fab cascaded through the supply chain and became a structural revenue cap for an entire generation of chip companies. Cambricon's rented ceiling is, in that sense, an industry ceiling. The reasonable counter is that this is temporary, that China is building its own lithography tools and will eventually close the gap. That may be true. Domestic Chinese semiconductor equipment development is ongoing and is receiving substantial state investment, but demonstrated production at competitive yield and volume using domestically built lithography tools at the nodes that matter for artificial intelligence chips has not been confirmed. Eventually is carrying a lot of weight in the optimistic version of this story. The gap between aspiration and verified production capability is measured in years, not quarters. Here is my honest read. The triumphalist version that sold out and 453% up means China's artificial intelligence chip industry has arrived and nothing can stop it. Ignores the fact that a business bounded by a ceiling it does not own is not yet a freely scalable one. The dismissive version that this is a hollow result, a Potemkin profit, that constrained supply means the win doesn't count, ignores that genuine market demand at this scale for a domestically designed chip is a real and significant result. Demand does not materialize out of policy. Customers are choosing this product. My read is that these are different things, and conflating them in either direction misses what is actually happening. Cambricon has proven the demand exists. It has not yet proven it can build a business proportional to that demand. A win bounded by a fab supply you do not own and cannot expand is real, but it is rented. The ceiling belongs to someone else. The real question was never why Cambricon cannot build more. It was always who owns the ceiling when you do not own the fab. Right now, the honest answer is that no Chinese fabless designer does, fully, not yet. So here is what I genuinely want your read on. Leave it in the comments. Is the demand proof the thing that matters most right now? The sign that the product has arrived, that the market has chosen it, and that the supply constraint is a solvable engineering problem trailing behind a real commercial breakthrough? Or does a ceiling you do not own and cannot raise mean the win is structurally incomplete until the fab problem is solved? Those are two genuinely defensible positions. Which one do you hold and why? Subscribe, because the story of whether that ceiling rises, holds, or gets replaced is going to be one of the most consequential industrial stories of the next 5 years, and we are tracking every move. That sold-out shelf is real. So is the wafer slot that never opened.